Namaskara students, welcome to V Karnataka KCET and boards. I am Diksha Kaushal, your chemistry master teacher. And students, here today we have our second lecture of chemical kinetics. Okay, let me see, there is so much echo in this room, right? So I am getting distracted. So guys, firstly let me know if is there any echo in the mic. If it is so, then please let me know in the chat box. And yes, now this is the second lecture of chemical kinetics. In our last lecture, we did what is rate of reaction, what is the order of the reaction, and today we are going to do a very important part of chemical kinetics, that is zero order reaction and first order reaction. And I can guarantee you that from this particular lecture, you will definitely see 1 to 2 questions. That minimum I am talking about. I am not talking about this full chapter, I am talking about this lecture that we are doing today, right? Because we are going to see 3 important topics. First is zero order first order reaction, right? What kind of numericals, and I will give you some direct tricks to answer those questions, right? Second is how to find the order of the reaction by different methods. They will give you hint about the temperature, they will give you hint about the half-life period, they will give you hint about the units, right? And they can give you hint about yes, they can give you hint about the concentration. Concentration is double, triple. So I will give you direct tricks specially made by your own Diksha Ma'am. Yes, students, so are you all ready? Everybody in the chat box. Khush Mohit. What a beautiful name. Khush Mohit, Gokul, Sandhya, Malapa, Gokul. Yes, Gokul again. Then Srinavas, yes, everybody. Okay, so now let us start the session without wasting any time. And here is your first thing. Okay, so everybody, firstly, we are going to talk about what was this order of the reaction. What was order of the reaction? What was the order of reaction? Everybody, let's recap something. Order of reaction, what was that? For example, I am saying that in some chemical reaction, you have R is equals to, rate of reaction is equals to rate constant. These are the reactants, that is, I am assuming it as A and B. This is A raised to power P. This is B raised to power Q. Now, what is going to be the order of the reaction? Order of the reaction is going to be N, which is equals to order of the reaction, or you can just directly write order of the reaction will be, in this rate law expression, what is your power on the reactants, right? That is P plus Q. That is going to be the order of this reaction. Now, this order can be zero order reaction, it can be first order reaction, it can be second order reaction, it can be third order reaction. But in your syllabus, we will talk about zero order and first order reaction. Okay, guys? Yes. Very good. Now, let us see what is zero order reaction. Very simple. It is nothing to worry about. Okay. Firstly, I will give you a hint about how to do derivation of this thing. Right? Very simple derivation it has. Right? After that, we will only focus on the formula, right? And there are different formulas here, right? So let us talk about zero order reaction. We will also talk about the graphs here. Zero order reaction. Now, zero order reaction, let us draw a line here, right? Let us draw a line here so that we are able to finish this off and our notes becomes really crazy and very beautiful notes you can get, right? Okay, so now what is zero order reaction? A very simple thing. Zero order reaction means, ma'am, order is going to be zero, right? So if you talk about the rate law expression was rate is equals to K, that is rate constant. Reactant, I am assuming everywhere reactant is A. I'll assume that reactant is A everywhere, right? So my reactant, in this reactant, there is zero power. Only then the order of the reaction can be zero. So here it will be zero. And in our maths, we know that anything raised to power 0, you have infinity raised to power 0. That will be 1. Anything raised to power 0 is always 1. So here you can write R is equals to K, right? Now from the differential equation, right, if I am saying that this is A give rise to B, this is your chemical reaction. So can you tell me, in the form of d by dt, in the form of differential law, what will be the answer of rate? We have two things. First is this rate law expression. Second is by differential method. By differential method, ma'am, we have rate of change of reactants divided by time is equals to, this is your K. Isn't it? This becomes dA by dt. This becomes dA by dt and this is your K. Right? See students, we know that from rate law expression R is equals to dA by dt. So R and R will become, so we can say that dA by dt is equals to K. Right? Now whenever you have differentiation, always you will have integration. So we'll multiply this to this side. Right? So this will be dA is equals to K dt. We will integrate it, right? Integrate this side, integrate this side. Now integration of anything, like integration of unity, right, of a constant, right, it will be equals to that thing only, right, that thing only. So here if you talk about the integration of dA, that will be A, that will be A, right, and integration of K dt, because K, that is a rate constant. So constant will be out of this integration and this will be dt, and whenever you are doing the integration of a unity thing, that will be what you have after the d, right, that is t, right, that will be the integration, right. I think Shreya sir has taught you integration and differentiation. He has taken up a lecture on that, right. So that is not only useful in physics, but it is also useful in fact, log and anti-log is not only useful in chemistry, it is useful in physics as well, right. Similarly, integration differentiation is useful in physical chemistry, right. So go through that basic lectures, right. Now here we know that the initial value, right, of any reactant you talk about, the initial value is going to be, let me see, the initial value I am taking it as, the initial value I will write it here only. I am taking it as A0 and final value I am taking it as AT. Here initial value I am taking it as 0, final value I am taking it as T. So it will become, the answer will become AT minus A0 is equals to KT, and this is your final answer. This is your final answer. This is the formula that you need to remember. For zero order reaction, what is the formula? The formula is AT minus A0 equals to KAT. And what is AT? That is the final concentration. For example, I am taking this, wait a minute. For example, I am taking that you have A to B is your reaction, right? Initially, we are saying that A0 was the initial reactant concentration. This was 0, right? A0 minus of something. I am saying X amount of it gets reduced, right? Now X amount of it is formed. Now I am saying the final concentration is, AT. So that's why initial and this is final, right? Here time is equals to 0 seconds. Here time is equals to t seconds, right? This is what we are saying when we are integrating it, right? When we are integrating it, this is zero order reaction, right? Zero order reaction. So this becomes your formula, right? Now, this is the first formula that you need to remember, right? Second thing is, they can ask you the graphs of this thing. How you can tell you the, how can we answer the graphs here? For example, here they're saying A0 is, AT is equals to, AT minus A0 equals to KT, right? If I want to draw a graph between, which thing? If I want to draw a graph between AT and T, final concentration and time, right? So students, always remember there is a straight line graph, that is y equals to mx plus c. That is your graph where y is what is in the y-axis, x is what is in the x-axis, c is the intercept. Intercept means where that line is touching the y-axis, not x-axis, y-axis, that is called the intercept. And m, that is called the slope. And usually they can ask you question based on the slope. that in zero order reaction, if you have a graph between AT and T, what is the slope, right? This they can ask you, right? So what we will do, we will compare it, right? So this will become your y. So to make it like realistic for you, so it will become like, so that this equation can match this equation, we can write AT equals to KT plus A naught, right? This will become equals to y equals to, this is mx plus c, right? So now, can you see the comparison here? Can you see the comparison here? Here y is nothing but it is AT. X is nothing but it is T. X is nothing but it is T. So m will become K and intercept will become A naught, right? So here it is a straight line graph, right? It is a straight line graph that is going in a positive slope because m is positive, right? So that is going in a positive slope. And here the intercept is A naught. Intercept is A naught means it will be like this. This will be your graph, right? And here we can say that intercept where this line is touching the y-axis, that is A naught, right? And this is a positive slope. So here we can write the slope is equals to K, right? Slope is equals to K. Yes. Okay, surely legend. I will surely make a strategic video on that. Okay. Yes. Now everybody, is that clear to everybody? So you just need to compare this thing, right? For example, they are not asking you, they are saying a different thing here. They are saying that, wait a minute. Yes. For example, they are not asking you this about this slope, right? Rather, what they are asking you is a different slope, right? A different graph they are asking you. They are asking you a graph between, for zero order reaction only they are saying, the graph is between AT minus A naught and T. What is AT minus A naught, everybody? AT minus A naught. What is AT minus A naught? That is KT, right? So we just need to write the formula here, that AT minus A naught is equals to KT. This I have to take it as y. So if this is my y is equals to, this is my mx plus c. So intercept will become equals to 0. Then this x will become equals to t, right? Y is equals to this thing and slope is equals to k. So here also the slope is positive, but that intercept is 0. That means it is going from origin, right? So you just need to check that what exactly they are asking you. You don't need to cram this thing here, right? You don't need to cram this thing that, ma'am, the graph between T and A naught was this, ma'am, the graph between T and AT was this, ma'am, the graph between T and AT minus A naught is this. You don't need to cram that thing. Why? You just need to understand this concept that y is equals to mx plus c is the graph of a straight line, where c is the intercept, m is the slope, and x is the time. That's it. And this is applicable also for first order reaction, right? When we will do first order reaction, right, the graphs will be totally different, but the concept is going to be exactly same, right? Okay. So that was the second kind of question that they can ask you. Now, third thing is what they can ask you is regarding half-life. They can ask you regarding half-life. Now, ma'am, what is this half-life, ma'am? What is this half-life, ma'am? Half-life means when 50% of the reactant, 50% of the reactant is consumed. When 50% of the reactant is being consumed, that means my AT should be equals to A naught by 2. Should I put it here? Should I put it here? Everybody, should I put it here? Here AT is equals to A naught by 2. If I put it here, it will become AT minus A naught is equals to KT. AT is equals to A naught by 2. This is A naught equals to KT, right? And this will become, this is A, wait a minute guys, let me see, AT, this is T minus, right, this is KT, yes, AT minus A naught, yes, okay. So now, this will become minus A naught by 2 is equals to KT, wait a minute, Wait a minute. Let me see if this is A naught minus 80 minus A naught. Oi hoi, one big mistake we have done here. Wait a minute. One big mistake, guys. One big mistake. That's why the answer is coming out to be wrong. Right? Wait a minute. Let me clear this out. The reactant, the rate of reaction we were writing in the form of which thing? Reactants. So in that case, it must be equals to minus dA by dt. Not dA by dt. Here also it should be minus. Here also should be minus. Here also it will be minus over here. So it will become not this. It will become, we skipped one minus here. So it will become minus of 80 minus A naught equals to KT, and this will become A naught minus AT is equals to KT. And similarly, if we put this equation here, it will be a different thing. It will be a different thing now, okay? Let me change the graphs here. Let me change the graphs here because it will become a different thing, right? So sorry about that. Yeah. So it will become a different thing because if you want to draw a graph now, right, between AT, the graph I am going to draw the same. Right? Do you see? I have not crammed anything here, right? I hate cramming, okay? I have not crammed anything here, right? I am telling you that how to do things, right? So here it is equals to that A naught minus AT is equals to KT. We need to draw a graph between AT and T, so it will become AT equals to A naught minus KT, right? If you want to write it, AT is equals to A naught minus KT. If you compare this with y equals to, this is your mx and this is c, intercept will become equals to A naught. That's why I was thinking that graph, the slope should be negative. M is equals to minus k, x is equals to t, y is equals to AT, and here intercept, because intercept is what? Intercept is A naught and the slope is negative, so graph will be like this. Okay, this will be the graph. This will be the graph where this will be your A naught and the slope is going to be minus k. Okay, the slope is going to be minus k. Okay, now let us change the other graph. The other graph was not like this. The other graph was between between what thing? The other graph was between T and, let's say, A naught minus AT, right? A naught minus AT, yes. Okay, the other graph was between A naught minus AT. This is the equation. If I compare this with y is equals to mx, so answer will be y equals to, this is mx plus c. Again, intercept is 0. X is what? T. Right here it will be t. Slope is what? K. Y is A naught minus AT. So here the intercept should go from 0 and it will be a positive slope because slope is going to be positive here. Slope is going to be k here. Right? Slope is m. That is k. That is turning out to be k here. Right? So it depends on what they are asking you. For example, they are not asking you a graph like this. Rather, they are asking you a graph between, rather they are saying that make a graph of T and AT minus A naught. Now, ma'am, what is the difference? Because the formula is A naught minus AT is equals to KT. So if you want to see what is AT minus A naught, take a negative of this thing. So it will become minus KT. And if you multiply this by negative, so it will be this thing. So minus minus it will become plus. So it will become AT minus A naught is equals to minus of KT. Right? That is going to be your answer. Now, this is your y equals to mx plus c. Intercept is 0 here. X is t here. And slope is minus k here. That is why here intercept is 0. That is the reason. Here it should be like this. Okay, what they are asking you, I'm just giving you different ways, right? How they can ask you the question, expand your universe here, right? So here they are asking you that slope is negative. It is going like this. It is negative slope. But the intercept is 0. Intercept is 0 starting from here. Slope is negative means it is going downside. Right? It is going downside. That is a negative slope. If it is going like this, it is a positive slope. If it is going like this, upside it is a positive slope. Downside it is a negative slope. Right? So now it is a negative slope. Slope is equals to minus of k. Right? Okay. Yes. Now that was about the graphs. Now let us see the half-life. Half-life means when your AT is equals to half of A naught. Right? So answer will be A naught minus AT equals to KT. Right? If you put the value of AT here, it will become A naught by 2 is equals to KT. It will become A naught by 2 KT. Right? So half-life, this is your T half, right? So T half is going to become, T half is equals to A naught by 2K, and that is also a very, very important thing, that half-life period is directly proportional to your initial concentration, right? Half-life period is directly proportional to initial concentration, right? Okay. Now, let us talk about the third thing, that is first order reaction. First order reaction, ma'am. What kind of reaction is a first order reaction? Simple. When your order is 1, first means 1. So when your order is 1, that is called first order reaction. Very simple, right? So same way we are going to do this. Same way, ditto copy paste we are going to do. What is the rate law expression for first order reaction? That is rate constant A raised to power 1, because order is 1. That is why reactant raised to power 1, right? Now, what is the differential equation? Minus of dA, right, by dt, is it? That is your differential equation, rate of change of reactant by dt. Negative because it is, we are talking about reactants here, right? This is Ka, is it? This is Ka. Now, let us integrate this thing, right? This is integrate this thing, but before integration, it will go here. A and A should be on same side, so it will be minus 1 by A dA, and this will be K dt. Now we will do the integration. From integration, here the initial value is A naught, final value is AT, here initial value is 0, here final value is T, right? Then we will do the integration here, it will become minus of integration, right? Minus of integration A naught, this is AT, this is 1 by A dA, this is K integration 1 dot dt. Now integration of 1 by x dx, integration of this is equals to natural log of x, right? Natural log of s, this is the x, this is value of integration, right? So here it will become this value, so it will be, this is natural log of A minus here, this is A naught, this is AT equals to K, here value will be T, it is 0 to T, right? So when you solve this, it will become minus of natural log AT minus natural log A naught, right? And this is KT, right? And this is KT. So it will become natural log of A naught minus natural log of AT is equals to KT. Now this is the first equation that you need to remember for first order reaction. There are different ways in which you can write it. I am writing the first in the second page. That is, first way you can write it is natural log of A naught minus natural log of AT. Just give me a minute. Yeah, sometimes weird things happens in a class, right? So it is equals to natural log of AT is equals to KT. That is the first way you can write this equation. Second way is natural log. This I told you in log and anti-log. This is the property, right? So if they are subtracted from each other, that means inside they are in the division form. That is A naught by AT is equals to KT. This is the second way of writing this equation. If you want to convert natural log into log base 10, you will multiply this by 2.303. right? So I'll multiply this by 2.303. It will become log base 10 A naught. This is log base 10 AT. I'll multiply this by 2.303. It will come in division over there, right? So I can write it as KT by 2.303. Or I can even write it as log base 10 A naught by AT equals to KT by 2.303. And these are the four very important formulas for first order reaction. Very important formulas, right? And definitely you will see a question based on first order reaction, right? For this formula, and this formula, they can ask you on the basis of graph. This formula is applied, the third formula is applied directly when we solve the numericals, right? Now, what kind of graphs you are talking about? Let us see. For example, I am saying natural log of A naught minus natural log of AT is equals to KT, is it? Now, for example, they are asking you a graph between two things. A graph they are asking you between two things, and what is that? Between two things, and what is that? A graph they are asking you. They are asking the graph between ln AT and T, right? So you have to convert it into y is equals to mx plus c, right? So let us convert it there. So if you want to have it a positive side, so it will be ln of AT, right? And this will become ln of A naught minus KT, right? Means this will become ln of AT is equals to minus of KT plus ln of A2. I have just rearranged it, right? I have just rearranged it. Now, if I compare this, it will become y is equals to mx plus c. C is the intercept. First, you would see what is y and x. Y is ln AT, right? This will become y. This will become y. What is x? X is t. This will become t. Okay, let's rewrite it with blue pen. This will become y. This will become x. So m will be equals to minus k, that is slope, right? And intercept will be equals to ln A naught, right? So can I write that what will be my, this is definitely a straight line graph. Slope is negative, that means like this. Intercept is ln A naught. So this is your ln A naught and this will become your intercept. So answer will be slope is minus k. They can ask you what is the slope of this graph. From this equation you can tell, right? Intercept is what? Intercept is ln A naught, right? So you don't need to, yes students, yes Abhishek, what is the, can you recap last graph? Okay, but ma'am intercept is 0. Where the intercept is 0? Where the intercept is 0? Yes, here I have taken this as origin only, right? I have taken this as origin. This is my origin only. Right? This is origin. Intercept means where it is touching the y-axis, right? So here I am saying intercept is 0, so it is touching over here, right? And here I am saying slope is negative, that means it is going like this. Slope is positive, that means it is going like this. Slope is negative, it is going like this, right? Okay? Understood? Yes, Abhishek, is that clear? Is that clear? Like in this point, at this point, what I am saying, intercept is this point where it is touching y-axis, and what is slope? That is negative, that means it is going like this, right? Okay, simple. Is that clear? Is that clear? Okay, perfect. Now for example, they are like, okay, let's draw another graph. Now try this yourself, everybody, try this yourself. They are asking you a graph between ln of A naught by AT and T. They are asking you graph between ln of A naught and AT and T. So ln of A naught by AT, the formula is like this. This is the formula I told you, no? This is the formula. See, this is the formula, right? That I have written here. So this will become y. This will become y equals to mx plus c. There is not any plus c. X is equals to t. X is what? T. Slope is what? K. So intercept will become 0. that means this will start from 0, that is origin, and the slope is positive, so it will go in a positive direction, that means here, right? It will go in a positive direction, that means upwards it will go, right? Upwards it will go. So here you can even write that the slope is equals to k. That will become the slope, right? Now a very asked question, if they ask you a graph between, very, very important question. They ask you graph between log base 10 of AT and T. Now say we know the equation is log base A0 minus log base 10 AT is equals to KT, right? Now I want to have it positive, so it will become log of A0, it will come to this side, minus KT is equals to, this log will come to this side, so it will become log of AT, right? Easy. Now this is my y, log of AT is equals to, this is what? Write it as it is, right? So I'm writing log of A0 minus KT. Now I will compare this with y is equals to mx plus c. This is y equals to, what is my x? X is time, so it will become mx plus c, right? So this is my c, this is y, this is x, this is c, slope will become equals to minus k, is it? Slope will become equals to minus k. Everybody in the chat box, tell me if that is clear to all of you or not. Only then I will go ahead if that is clear to you. Okay? Yes, everybody. Krishna, Kavya, Abhishek, Legend, Srinivas, Gokul, Sandhya. Yes, everybody. Is that clear? How I am drawing the graphs? Are you able to draw those graphs? Because that's why I am giving you so many practice questions based on this, so that you are able to draw the graphs yourself, right? So here, intercept is A0, right? Slope is negative, that means downside it is. Intercept is what? Intercept is log of A0. Wait a minute, one thing we forgot to have here. That is 2.303. That is 2.303. That is 2.303 here also, right? Here also it should be 2.303, right? So it will be log of A, wait a minute, this will be, this will come to this, yes, log of A0 minus K by 2.303, this is T. Now, you compare this with y is equals to mx plus c, this is c, this is mx, so this will become x, this whole thing will become slope, this thing will become intercept, right? So now y is log 80, x is time, intercept is minus k by 2.303. So slope is not minus k, slope is minus k by 2.303. And what is intercept? That is log A0. Okay? What is intercept? That is log A0. Right? Similarly, one last graph I am drawing here. They can ask you that draw a graph between log of A0 by 80 and T. Now again the same thing we will do. Again the same thing we will do here. Right? That is log of A0 by 80 equals to KT by 2.303. Simple. We will compare this. Y equals to mx plus c. Right? Here, this thing, this x is this thing. So, m will become, this whole thing will become m. And y is this thing. Right? So, here, if you talk about the intercept, intercept is nothing, nothing here, nothing plus, mx plus nothing. So that means intercept is 0. Slope is positive or negative? Slope is k by 2.303. That is positive. So your answer will become slope equals to k by 2.303. Right? What is c? Intercept is 0. Slope is equals to k by 2.303. Is that clear to everybody? Right? So that was about your first order reaction graphs based on these four formulas. Again, I am saying you don't need to cram these graphs. Don't do that you yourself, right? Instead, just remember this thing and compare it with y is equals to mx plus c. Y is y-axis, x is x-axis, m is slope and c is the intercept, right? Just do that based on what they have asked you in the question. And what they can ask you, I have already done, right? Apart from this, they can't ask you anything else, right? Okay, so that is, I have already covered that thing. Now, next is, what is half-life period? What is half-life period for this one? What is half-life period for this one, right? Half-life period is 50% is consumed. That means AT is equals to A naught by 2. So just write it here. We have the equation. Whenever you are doing the numericals or putting any value, you will always use this formula, that is log of, like you will use the formula of log, right? Not natural log, but log base 10, right? So this is log of A naught by AT is equals to KT, right? What is AT? That will become A naught, right? Divided by 2, right? So it will be 2 here, it is KT, right? It is 2 here, it has become KT. So the answer will be, this is 2.303. I forgot to write 2.303. Yes. Okay. Yes. So now it will become A naught will cancel each other. It will be log 2 equals to KT by 2.303. Right. It is KT by 2.303. Right. Now this will become, what is the value of half-life? Because this is the half-life now, right? This is the half-life because 50% is consumed. So it will become T half equals to, it will come to this side. So it will be 2.303 log of 2. It will come to this side by K. It means T half of first order reaction will be 2.303 multiplied by 0.301. That is the value of log 2. Right, that is the value of log 2, that is 0.301, right, divided by K, and always remember this will become equals to T half equals to 0.696 divided by K, right, and that will become your formula, right? Let me multiply that. Point will be approximately this one only. 0.301 multiplied by 2.303. Yes, 0.693. Sorry, it is 0.693. Right? It is 0.693. Now, this is a very, very important formula. And here, can you see, it is not dependent on the initial concentrations. A very important point is not dependent on, very frequently asked question, not dependent on not dependent on initial concentration, okay? It is not dependent on the initial concentration, okay? Yes, students, okay, very good. Now, yes. Now, another way this question can be asked based on natural log. So, you can write it as natural log of A naught by AT is equals to KT. We know that KT is, if we are talking about KT, if we are talking about half-life, so it will be A naught by 2 and this will become KT half. Because if I am saying T half, when 50% of the concentration is consumed, half-life period, then this will become AT is equals to A naught by 2, right? A naught will cancel each other. This is natural log of 2 is equals to KT half. And this question, that T half is equals to natural log of 2 by k. This is also an important formula. Though for numerical purposes, you will use this formula, but they can ask you the same question based on natural log also. Right? Okay? Okay, students? Yes, Palgam, in the end I will reply. Okay? In the end I will reply. Firstly, let's focus on the concept. Right? Now, that was the first order reaction, right? Now, ma'am, on what ways the questions can be asked, right? On what ways the question can be asked? A very simple. Now, in next 10 minutes, I'm going to talk about tricks. Now, next 10 minutes is going to be very, very important because till now I was doing the derivations and all, right? I have told you the formulas. Now, I'm going to tell you the tricks. Trick for half-life period. Half-life period. Half-life period, directly write. You need to remember the formula also, and also you can remember this thing that T half is directly proportional to initial concentration raised to power 1 minus n. If you put, if n is equals to 0, then T half will be A naught, right? If n is equals to 1, T half will be directly proportional to A naught raised to power 1 minus 1. That means 0. And anything raised to power 0 is 1, right? That means it is not proportional to, this is not proportional to, that means this is independent. Independent. This is the same that we did from the derivation. Now I am telling you very good evening. Now I am telling you about direct tricks, right? So if they ask you n is equals to 2, you'll say, ma'am, very easily we can do this. T half is A naught raised to the power 1 minus 2. What is 1 minus 2? That is minus 1. What is minus 1? That means 1 by A naught. That means it is inversely proportional. Here you can write directly proportional. Here you can write inversely proportional, and a very, very frequently asked question. Zero order reaction, T half-life is dependent directly, inversely, independent, none of these of the initial concentration. Zero order directly, first order independent, second inversely. How? From this formula directly. From this formula, T half is directly proportional to A naught 1 minus n, direct formula, right? Okay, understood? Yes, students? Now, let us see in questions how to apply the formula. They will ask you numerical base, most probably, I can give you the highest probability that if they ask you numerical from this is either from Arrhenius equation or from first order reaction, right? So now, let us talk about the first order reaction. The formula is log A naught minus log AT equals to, or you can say log A naught by AT equals to KT by 2.303. Or you can calculate time from here, right? Or you can calculate T, that will be equals to 2.303 by K, right? So this will become the formula. This is your formula. Now you need to see how to apply this formula. A simple trick I am telling you. Either they can ask you directly, A naught is 100 mole, AT is 150 molar. Directly put the values. You will get the value of, they will ask you T or they will ask you rate constant. You just have to put the values that are given in the question, right? Simple. But the tough part is when, ma'am, it is not given. Ma'am, they have not given us initial concentration, final concentration. Ma'am, they have given us in the form of percentage. Ma'am, they have given us in the form of fraction. What to do, ma'am, now? Simple. Two things I am doing here. I'm dividing in two parts. First is, even now I am dividing into two parts. Means 4 parts I have divided it. Right? Here, if they ask you X% is consumed. Consumed means it has been reacted. X% is consumed. So your initial concentration here is going to be 100. So it will be T is equals to 2.303 by K log initial is 100. 100 divided by what is final concentration? Two things. When you talk about percentage, take initial concentration as 100. When you talk about fraction, take initial concentration as 1. That is about difference between percentage and fraction. If they ask you consumed, that means from initial concentration, X% has been reacted. That means it will be 100 minus X. Right? If they ask you Y% or they ask you, just I'm saying X% is left. Right, that means the remaining thing is X%. They are not saying X% is consumed. They are saying you are eating the pizza, right? And how much? I am saying I have eaten 2 slices. That is this thing. Ma'am, I have not eaten 2 slices. Ma'am, there are 6 slices in the plate that is still left, right? That means the final concentration they are giving you X%. So here it will be T equals to 2.303 by K log base 10. Initial concentration, take it as 100, right? How you will take initial concentration as 100? Simple. Initial concentration 100. Whenever in percentage it is given. If they have given you the value, simple. If they have not given you the value, they will either give percentage or they will give in the fraction, right? So it will be 100. This will be simple X. Why this will be simple X? Because this much amount is left, right? So it will be X. For example, 25% is left. So it will be 100 divided by 25. For example, they are saying 75% is consumed. That means 100 by 100 minus 75. 75% has been consumed. Here we are saying that X is left. X is consumed. For example, they are saying 1 by 4th is consumed, 3 by 4th is consumed, 1 by 2th is consumed. This is the fraction. So whenever it is in fraction, you will write it as 2.303. This is the formula. Log base 10. Take the initial concentration as 1 if it is given in fraction. It will be 1 minus X. For example, they are saying 1 by 4th is consumed. So here you will write 1 by 1 by 1 minus 1 by 4. This will be inside the log, right? This will be inside the log. Now, for example, they have given you X is left behind. Left behind. That means X is left behind, right? X is left behind. Now, T, you can say T here, you can write K here. That is totally your choice. Right, what they have asked you. If they have asked you the value of K, you will write T. If they ask you the value of T, you will write K here. So it's not even a question, right? So T is equals to 2.303 divided by K log base 10. Initial, that is 1. Initial, you will, in fraction, initial is 1. Initial is 1, X amount is left. That will be 1 by X, right? That will be 1 by X. Now, students, tell me, is that clear to everybody? Is that clear to everybody? Is there any problem in this? Is there any problem in this? Maths and maths, you can watch my lecture of log and antilog. You will get a proper knowledge of what is the difference between ln and log, right? Okay. Students, everybody in the chat box, tell me if that is clear to all of you or not. If that is clear to all of you or not, everybody in the chat box. Everybody in the chat box, tell me if that is clear to you guys or that is not clear to you guys. Okay? Okay, yes. Now, next is a very important concept, that is Arrhenius equation. Arrhenius equation. So Arrhenius equation is basically This is K is equals to, I'll give you two ways we can write this equation. It is K equals to A e raised to power minus EA by KT, EA by RT, where K is rate constant, A is Arrhenius constant, EA is very, very important, activation energy, R is gas constant, that is 8.314, right? T is temperature in Kelvin. This is universal gas constant. Okay. Now, see one thing. Here, first so you need to know, you all know what is rate constant. We have done it in rate law expression. What is A? Because Arrhenius equation it is, that is why there is a new constant that is called Arrhenius constant. You don't need to know the value of this thing, right? So simply just remember Arrhenius constant this is, right? They can ask you activation energy. What is EA activation energy? R you know, T you know, that is temperature. Now ma'am, what is this activation energy? That is the new thing for us, right? So activation energy means, for example, this I am saying this is your energy, this is energy, and this is reaction coordinates. This is reaction coordinates. So in reaction coordinates, whenever I am converting a reactant to product, right, in that conversion, it transforms into an intermediate state, a transition state in which the activation energy, is called the activation energy, right? And this reactant need this much amount of energy to get converted to product. This I am saying is the reactant, right? And this need this much energy to get converted to the product. Otherwise, it will be difficult. It is not possible. Why certain reaction does not happen? Because they don't have activation energy is one of the reason that some reaction does not occur in reality, right? So this activation energy is needed. Like to crack any exam, there is certain amount of marks that you need, right? For example, to pass board exams, you need at least 33%, right? Otherwise, you will be failed, right? So you have a threshold. Above that, if you get that many marks, only then you will be called as pass, right? So in the same way, there is this activation energy so that reactants can get converted to products. Now, we know that in chemistry, energy is inversely proportional to stability, right? If my energy is very high, I am like crazy, right? So what will happen? My stability is low, right? I am not sitting somewhere. If my energy is very high, if my energy is very low, I'll just lie down, right? So similar, energy is inversely proportional to stability. Because here, intermediate state has the highest energy among reactant and product. That is why intermediate states are not stable. They are unstable. That is why the life of intermediate or transition state is very less. That you have studied in organic chemistry, that intermediate state have the very, very unstable state. They have very less life. Okay, understood? Now, if you talk about Arrhenius equation, if we take the log, this can be written in a different way. If we take the log here, this is K is equals to A e raised to power minus EA by RT. You take a log here, it will become ln K equals to, this will become ln K equals to ln A E, and this will cancel out, this will become EA by RT. If you want to convert it into log base 10, you don't need to do derivation in KCET, right? I am just telling you derivation so that you also know that what is exactly happening here. Otherwise, I'll tell you in the end what are the formulas that you need to remember. Take the log here. This will be log. Convert it into natural log. Log base 10. Log K. This is log A minus EA by very, very important formula RT. these are the three, these are first formula. This formula you need to remember, this formula you need to remember, right? From here also they can ask you one graph, from here also they can ask you one graph. The graph can be, the graph that they can ask you is, for example, they are asking you, draw a graph between log k and t and 1 by t, right? They are asking you to draw a graph between log k and t. So what you will do? You will take this as y, right? This thing as, not even this thing, this 1 by this thing as x because it is 1 by t. This thing as c, intercept, and this thing as m, slope, right? So it will be y is equals to mx plus c, right? So here that means the intercept is ln a, log a, slope is ea slope is negative, that is minus ea by 2.303. So this is the slope, this is the slope. Intercept is what? Intercept is negative, intercept is log of a, I'm putting it here, and slope is negative. They can ask you very, very important question, what is the slope here? That is minus ea by 2.303 r, right? Okay, maybe another 10 minutes, right? So that is your slope. Okay, students? Yes, everybody in the chat box, is that clear or not? 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 Right? In the same way, you know, they can even ask you that what is the, wait a minute, what is the graph of ln of k and 1 by t? Simple. You convert it. This is your y equals to mx plus c. If this is the intercept, that is ln a. What is x? X is 1 by t. So this slope will become minus ea by r. So here intercept is ln a and slope is minus ea by r, right? So these are the graphical questions that they can ask you, right? Okay, and one last equation I am writing, I am not doing the derivation part here. Log of k2 by k1, because derivation is not necessary, it's not required in your competitive exams, right? So what you have to do, you just have to use this particular formula. Just use this formula for, at one time there is temperature T1, rate constant K1, another temperature T2, rate constant is K2. But activation energy and Arrhenius constant is same. Subtract it, you will get this derivation and the answer will be log K2, very, very important, log K2 by K1 Ea by 2.303 r 1 by T1 minus 1 by T2. You can remember this, or you can remember log K2 by K1 equals to Ea by 2.303 r. This is T2 minus T1 divided by T1 into T2. Okay, students? Okay, students, so this is your second. This is very, very important formula and easily question can be asked. They can ask you activation energy. Most probably they will ask you activation energy out of this. Yes, students, most probably they will ask you activation energy from this. Okay? Okay, guys? Yes? Now, last part of today that I was supposed to do yesterday, but yesterday we didn't have time, so that's why I'm doing it today. How to find T? I'll give you simple direct methods. how to find order. If they ask you order, they will give you certain hints and I will give you direct trick for that, right? I will give you direct trick for that. First is, if they are saying hint on concentration, they have given you hint on concentration, then what you will do, I will give you direct, otherwise this is very tough part, okay? I am giving you direct equations here, okay? Direct equations. See what they will give you, that your rate is doubled, when concentration was doubled, what is the order? Rate is 4 times when the concentration is doubled, what is the order? So just remember one thing, R is equals to x raised to power n R. This is your new rate, this is your old rate. Okay, this is new rate, this is old rate. For example, they have given you, and one thing to remember here, n is order, x is the concentration doubled, concentration times. How much time? Not time, how much concentration increased? Like 3 times, 4 times, 5 times, how much, right? So I am giving you one example here. They have given you one example. Rate is 4 times when concentration doubles. They are asking you what is the order of this reaction, right? What is the order of this reaction? Simply do this thing. Rate is 4 times, that means new rate is 4 times old rate. First equation, what they have given you in the question. From this formula, we have, this is the formula that I have made, right? From so many questions, solving so many questions, right? So, hardly, I don't think so. I have not seen this formula in any book, right? So, I would say, simple direct tricks I have given you. So, just go through them, right? New rate is equals to 4 times this. So, this is x raised to power n R of old. That means, can I compare these things? R new, R old, means x raised to power n is equals to 4, right? And what they are telling you about concentration, it doubles. That means x they are saying is 2. So, can I write this as 2 raised to power n? Students, tell me, can I write it as 2 raised to power n? Is this thing clear to everybody or not? Yes, today this is complete only. Today I'll complete this only, right? Last topic we are doing, right? We have completed first order, second order reaction, right? We are doing how to find order. We have completed our Arrhenius equation, right? So now we are doing how to find order of the reaction, or different things they can give you, right? So new order is equals 2 raised to power n, rate of volt. So that means here 2 raised to power n is equals to 4. When 2 raised to power n can be equals to 4? When n is equals to 2. Because 2 raised to power 2 is equals to 4. 2 square is equals to 4. That means order of the reaction is 2. Yes, order of this reaction is 2. Okay, students, will you be able to do this? Yes, everybody in the chat box. Yes. Now, next is, they have given you hint for half-life. And initial concentration. So this to directly you can say, if they give you that, so directly you just need to remember this thing, that T half is directly proportional to A naught 1 minus n, right? A naught 1 minus n, right? Now either they can give you directly that it is independent of initial concentration, it is dependent on initial concentration. That's the first way they can give you this, right? Or second way is one, so they can give you on the basis of that this is independent, this is dependent, that I have told you how you will do that. For independent, what is the order? For dependent, directly, what is the order? For inversely, what is the order? What if they give you the value of, they have given you two conditions, T half first, T half at second time. Here the concentration is A naught, initial concentration is A naught 1, initial concentration is A naught 2. Initial concentration is A naught 1, initial is A naught 2, right? Very rarely they can ask you this, right? But still, see what you will do here. I'll directly write the formula only. Chalo, I'll do the derivation, but you don't need to remember the derivation, okay? You just need to remember the direct formula, right? So basically it will be T half of 1 is directly proportional to A naught of first condition. T half of second is directly proportional to A naught of second 1 minus N. Two conditions I am giving you. When your initial concentration is A naught of 1, then T half is T half of 1. When initial concentration is A naught 2, then T half is T half 2. Right? Okay. Understood? Now, you just divide these two things, you will get T half of 1 divided by T half of 2 is equals to A naught of 1, A naught of 1, 1 minus N, A naught of 2, 1 minus N. Right? A naught of 2, 1 minus N. Right? A naught of 2, 1 minus N. Take 1 minus N common, it will be A naught of 1, A naught of 2. Why I am erasing it? Because you don't need to derive it, okay? I am just doing the derivation here, okay? So that you also understand where I have written this formula from. Then take a log here. You will take a log here as well, right? Take a log here. Take natural log here. You take the natural log, it will be 1 minus N because the power will come in the front. It will be natural log of A naught of 1, A naught of 2, right? Now, if you want to calculate the value of N from here, it will be, N will be, this will come in the division, it will be divided by ln of A naught 1, A naught 2, right? That is 1 minus N. 1 minus N. So N, if I take it here, N will be equals to, wait a minute, and if I take it here, minus will be here. So it will be N, if I take it there, it will be here. So it will be natural log, it will be like this. Yes, it will be like this. The answer will come out to be N is equals to 1 minus natural log of T half of first condition divided by T half of second condition, T half of second condition divided by ln of initial concentration of first condition, initial concentration of second, right? This will become your final formula, right? You don't need to do this derivation, right? You don't need to do this any derivation here, right? You just need to remember this thing. For example, they have given you when A naught was 50 molar, T half was 25 seconds. When A naught was 100 molar, T half was 50 seconds. What is the order of the reaction? So what you will write, N is equals to 1 minus natural log, right? Natural log of, you can write it as natural log of, this will be, wait a minute, you have taken log on both sides, right? Take a log on both sides, it will be, yes. You can write here log also. Do you know why you can write here log? Because 2.6 will be divided by each other, right? Because if you convert it into log base 10, it will be 2.303 divided by, and also this will be 2.303. That they will cancel out each other. That is why I am writing it as log base 10 only, because you don't know the value of natural log, right? You know the value of log base 10, right? So here it will be 1 minus log base 10. This is your first condition. This is your second condition. So this will be, first will be 25 by 50 divided by, this is 50 by 100. This is 1 by 2. This is also 1 by 2. In fact, they will cancel out each other, right? This will be 1 minus log 1. This is log 1. Either ways, log 1 value is 0 only. So it will be cancel out. It will be n is equals to 1. This kind of question I am saying. Okay? This kind of question I am saying. Okay, students? Yes. Okay. This type of no, but this type of problems, yes. Right? Depending upon concentration, yes, they can ask easily. Even I have seen in previous year board questions, they can ask you this kind of question. But this is, no, this is competitive. Basically, this they can ask you in competition level, right? But this is also very simple, no? It's very simple, right? You just need to remember this thing. T half of first, T half of second divided by A naught of first, A naught of second. Simple. Was it difficult? Was it difficult? Difficult is when you have not seen this formula, right? If suddenly in the exam it will appear, then you will get, ma'am, I have never seen this formula, ma'am, right? But now you know the trick. You know this trick as well. You know this trick. You know this trick. You know this trick. So it is very easy for you now, right? Now third one is, it's a very frequently asked question, hint on temperature. Hint on temperature. But here we are not going to find the order of the reaction, right? Here what we are going to do, see, right? Here we are not going to find the order of the reaction. We are going to find the temperature. Temperature dependence. Temperature dependence of rate constant. So it was seen experimentally that when there is 10 degrees Celsius or 10 Kelvin rise in temperature, rate constant, this is experimentally defined, rate constant is doubled. Rate constant is doubled. Now you will say, ma'am, 10 degrees Celsius or 10 Kelvin change. What you are talking about? Achha, tell me one thing. If I say 323 Kelvin minus 313 Kelvin, that will also be 10 Kelvin. If I say 100 degrees Celsius minus 90 degrees Celsius, this is also 10 degree. I have just changed the unit. With changing the units of this absolute value of this Kelvin and degree Celsius, my difference has not changed, right? My difference is same only. So if in the question they write degree Celsius, in some books you will say, ma'am, they have written degree Celsius. Some books you will say, ma'am, they have written Kelvin. Ma'am, is this book wrong? Is this book wrong? No, both are right. Because change is same only, no? Right? Change is same only. Right? Because whether you talk about this Kelvin change or degree change, change is 10 degrees Celsius is also same change. 10 Kelvin is also same change. Right? So there is no difference in that thing. Right? So that is experimentally defined. 10 degree or 10 Kelvin rise in temperature, it will cause rate constant will be doubled. Okay? Rate constant will be doubled. A very important thing. Next is, they can ask you what kind of question. So I'll give you one simple trick. Students are usually, thinking and writing. This will take 2-3 minutes, maybe 5 minutes sometimes. Still they will answer it wrong. I'll tell you how to solve this. See, first is one conceptual question they can ask you. Other is a numerical they can ask you. What kind of numerical? They will give you new time, new temperature, minus old temperature divided by 10. First, you just need to remember this formula. I'll tell you how to apply this. Then, they will ask you new rate. What is a new rate? This is now the formula. Now, I'll tell you how to apply this formula. Okay. Now, I'll tell you how to apply this formula, what I have written here. right? What I have written here, right? How to apply this formula. Very, very good evening. Very, very good evening. No issues, Mandar. You can always watch the recorded version. But yes, I would love to see you guys in my live classes. Okay. So now students see, for example, in the question they give you, the question is that on heating, the temperature is raised from 428 Kelvin to 728 Kelvin, right? Yes, right, 428 to 728 Kelvin, right? Or you can say just simply write it in degrees Celsius, right? 10 degrees Celsius to 40 degrees Celsius, right? Because this much temperature variation only they will give you. You can write 60, whatever you can write. You can convert it into Kelvin. 283 Kelvin to this 273 plus 60 is what? Right, this much Kelvin. They can give you even in Kelvin, right? So this is 10 degree to 60, I am assuming they have given you. Calculate how many times rate constant has increased. Right? Rate constant, right? Now, otherwise you will think, okay, with the 10 degree rise in temperature, the rate constant is doubled. Here it is 10 to 60 degree rise in temperature. How many degree rise in temperature? 50 degree rise in temperature. For every 10 there is twice. For 50 degree it will be 2 into 5. And some of you might not be able to understand this, right? You will be like, ma'am, I got puzzled. So simple way of doing this is simple way. That is, calculate the value of m. M is what? I don't know what is m. I have just given you a number of m, right? Because I told you that this is not a bookish trick. This is what I have made, right? So m is not any constant, right? M is just a number, right? There is some number when you have new temperature minus old temperature divided by 10. New temperature is given to be 60. Old is 10 divided by 10. It will be 50 by 10. So answer is 5. Answer is 5. So what is new rate constant is 2 raised to power m. Old rate constant, that is equals to 2 raised to power 5 of old rate constant. So that means 2 into 2 into 2 into 2. K of old, it will become, wait a minute, one more time, 2 to 4, 2 to 4, 4, 4, 16, 16 to 32 old rate, right? That will become your answer. That will become your answer. Is that clear to everybody or not? Everybody in the chat box, is that clear or not? Is that clear to everybody? Yes, everyone in the chat box, is that clear or not? Hanji. Is there any trick shorter than this? What is this, guys? This is short trick only. Do you want me to shoot the subject only? The subject will die if I make more short tricks like this. How? Because what you want me to do? You want me to just tell you the answer of the question. That will be short trick, right? Short trick is A, B, C, D. Just close your eyes and answer A, answer B, answer C. That is the shortest trick, right? Otherwise, these are short tricks only. These are short tricks, right? M is equals to this, K is equals to 2 raised to power M, right? This is short trick. This is your short trick. This is short formula, right? This is also short trick, okay? Right? These are the short tricks that you need to remember, and these are the formula, a very, very important formula, right? Then this particular thing, this is exactly, right? This is also after so much of hard work, right? I have given you this direct thing so that you can answer any question, right? Based on this particular thing, right? Then we have this formula. Then we have this trick. that T half is directly proportional to A naught raised to power 1 minus N. This way you can directly answer that whether it is directly, inversely, which proportionality sign you have, and then that will become your answer. Okay guys? Yes, everybody in the chat box. Everybody in the chat box who attended today's class. Is there any problem? Right? Okay, Khush, Rohan, Sheetal, Mandar. Okay guys, so that's it about today. Now I'll start electrochemistry from next week. Yes, and I'm very excited for that. I hope so you guys are also excited for that. Now I want you guys to try solving some question from these formulas. Directly you will see it will be very simple for you to apply the question. And don't worry, I'm going to take up your practice session as well. We are going to solve the question here itself on this channel. Don't worry on that, right? But right now we are going through physical chemistry, 12th class basically, right? Chemical kinetics, electrochemistry and solution. That is my main target, right? After that, we will start doing the numericals also. Okay, yes. This chapter is over. This thing is enough for you. Right? Okay then guys, bye. Take care. See you all in the next class. Till then, don't forget to hit the like button. Don't forget to comment below because I do see your comments. I even comment back. I even reply back, right? Okay. And also one more thing. If you like this video, also share this with your friends, right? So that we can spread this knowledge among other students also who are in need, who are sitting there at their home and right now they don't know which teacher is going to teach them in this way, right? And the notes will be provided on Telegram channel. The link is in the description of our Telegram channel. And that's it. Okay then, bye-bye. Take care. Till then, keep smiling and keep spreading the love around you. Bye-bye.